Hello guys, and welcome to the material properties lesson in engineering principles on LearnIO. This is going to be our last lesson for this engineering principles course. But if you do want to learn more, I do recommend you go ahead and take a look at our engineering principles advanced course. Some of the math topics that we cover on there are going to be more advanced, as well as some of the concepts that we cover. But it's definitely a great idea to check it out, especially if you want to challenge yourself just a bit. So, why does material choice matter? Well, think about it. Every material has different properties. Some of them are really hard, some are really soft, some of them are really strong, some of them shatter on impact. And engineers need to be able to use these properties to their advantage, to be able to build the strongest structures that they possibly can, or if they don't need to build something that's super strong, keep costs low while still being strong enough to withstand any forces that the structure will be experiencing. I mean, for example, imagine if the Golden Gate Bridge were made entirely out of wood. Would that be able to withstand the forces of thousands of trucks going over it every day? I don't think so. And that's why it's not made out of wood. That's why back when we were building with only wood 300, 400 years ago, we didn't have bridges the size of the Golden Gate. They just couldn't withstand that amount of force. So with that in mind, let's go a little bit into the mechanical properties of materials. So you'll see I have 4 mechanical properties listed on the side: strength, hardness, ductility, and stiffness, and I have their definitions, or brief definitions of them, written right underneath. And you'll notice I keep saying mechanical properties because there's actually other types of material properties. There's thermal properties, electrical properties, chemical properties, but we won't really be going into those properties today just because they require a level of understanding of their respective fields, be it thermodynamics, chemistry, electricity, whatever it is, that we just can't really get into in a short video or a short course like this. So let's try and understand these 4 mechanical properties a little better first. So we have strength, which is the force a material can withstand. So right over here on the right, I have a graph that I actually got from researchgate.net, and it's what we call a stress strain graph. So we won't really be getting too much into how to understand a stress strain graph, how to create one, and really explaining it in detail here. We may go over that in the advanced course at a later date. But what you need to understand is that this region right here, called the elastic region, so long as your material is experiencing a force within that elastic region, any deformation that happens to it, any amount that it stretches or compresses, will return to normal after the force is removed. Once you reach the plastic region, any amount of deformation, be it compressing the material or stretching it, any amount that you've stretched it or compressed it is permanent. So the amount of strength a material has is determined by its failure point right here at the end. That's basically how much total force can the material take before it breaks. That's its ultimate strength. The hardness of a material is its resistance to permanent deformation, meaning how much can it deform elastically before the deformation becomes plastic. One way scientists and engineers test the hardness of different materials is by pressing a tungsten carbide ball into the material with a set amount of force. They then remove the ball and measure how big of a crater it created. And that tells them how much basically how much the material resists deforming permanently. So the ductility of a material is how much it's able to deform before it breaks. For example, if you have a really hot metal, if you've ever seen any of those 1,000-degree knife videos on YouTube, the metal actually can stretch quite a lot without breaking. Now, if you compare that to glass, you can't stretch glass at all. If you try to, you'll just shatter it. That's basically how ductile or inductile a material is. So a really ductile material is able to stretch a lot. It has a really, really long plastic region that just keeps going before it finally breaks. Whereas a material that doesn't have a lot of ductility might have a really short plastic region, might end like right here, where it just breaks as soon as it starts to deform at all. And so the stiffness of a material is its resistance to deformation. So for every unit that this graph goes right, how high up does it go? How much force do you have to put into the material before you can start to deform it? So while ductility measures how much it can deform before it breaks, stiffness doesn't really care about when the material breaks. It cares about how much force you have to put into it to be able to bend it. So let's take again the aluminum and maybe glass. The aluminum has a really high ductility compared to glass. Any metal you can stretch quite a lot, especially if you heat it up. Whereas glass, you really can't stretch unless you've melted it. But the aluminum also has really high stiffness. It means that it does take a lot of force to be able to deform it. That's just because aluminum as a material is really strong. It takes a lot of force to stretch it, but once you're stretching it, it can stretch quite a lot without breaking. Glass, on the other hand, especially unstrengthened glass, doesn't deform a lot, and it really doesn't take as much force to start deforming the glass. So that means that the glass has a low stiffness and a low ductility. So hopefully that helps you understand some of these mechanical properties a little better. For more in-depth understanding of engineering principles as a whole, I'd recommend once again that you look at our Engineering Principles Advanced course. Now that you've done this course, you should have a lot of the base knowledge needed for that, although the math concepts that we go into there may involve some basic geometry and trigonometry, although once again, we'll try to keep that as simple as possible since we know that not everyone has taken those courses. So I hope you've learned something today, and I hope to see you there. Thank you.